All right, now I want to kind of reset where we're at. And we are focusing, and the exam that we'll have Thursday is focused on what branch of inferential statistics? What have we been doing? What branch of inferential statistics? Come on, what have we been doing? That's why we need a refresher. What have we been doing? Under inferential statistics, there's two major techniques. One is estimation. The other is, Max, the other is?
What?
The other is estimation and, Lauren, hypothesis testing, right? So if we think about it, and I want to think about it, and I want you guys to help me through this. When we do hypothesis testing, we start out with two hypotheses. Roger, give me one of those. Okay, the first one is the null hypothesis, H sub null, and that is what we assume to be true at the beginning of this. You guys recall? Yes? So what is the other one? The other one, Sophia, is the alternative, and that is what we're trying to prove at the beginning of this, right? So an example of this, let's say I'm trying to prove that the average distance traveled by St. Francis University students over spring break was greater than 500 miles. So my set of hypotheses would be like this, right? I'm trying to prove greater than 500. So we always start out with two hypotheses. The next step, we say, all right, let's set up our tests, right? That's what we're trying to test. Let's set up our test. So where is evidence? If it's greater than, what's the evidence? Where is the evidence? What kind of tail test would we have here? Brooklyn, what kind of tail test? If it's greater than, we'd have what kind of tail test? Where would the evidence be? Very good. It's a right tail test. So we would do something like this. We'd say, all right, if we're assuming it's 500 at the beginning of this, and I'm just going to throw a standard deviation of 50 to make it easy. We know evidence is over here. And what do we call this region where if the evidence falls in there, we have enough evidence? What do we call that region? Do you remember what it's called, Roger? It is called the rejection region. Now that is definitely going to be on your exam as a multiple choice, right? That's called the rejection region. What defines the rejection region? What defines where we set that bar? What is the term that we use to say where we set that bar? What is it? What is the term that we use to set that bar? Yes, sir. Okay, and what determines where we set that bar, though, Max? Like, what is the area of that rejection region?
The alpha value.
Very good. Alpha, the significance level, right? Alpha is the significance level. And really, it's the probability that we're wrong, right? So remember, confidence level was the probability that we're right. So significance level, 1 minus alpha was confidence level, percentage of time we're right. Alpha, significance level, percentage of time we're wrong. And what's the biggest significance level we're ever willing to accept in the world of statistics? What's the biggest significance level we're willing to accept? Max?
90.
Well, 90% is the minimum confidence level, so 10%, right? So usually I'm talking about 10% or 5% or 1%. So let's just say the standard one is 5%. And we're going to say, all right, well, here's the deal. It's a right tail test. And so if we go over here, we're going to go into Z world. And we know that there is a Z value in the same boat. And remember, I gave you a little table, but you might remember this. If alpha is 5%, what is this rejection region in terms of Z? You guys remember? It would be 1.645. Do you guys recall? That's the standard one, 5%. I would, or I could, if you recall, I can convert this back to find an x lower bound. And the formula I do that with is this. I'm not going to do the math because I'm really just want to kind of talk about the concepts. But that's how I get from that rejection region over to the X bar rejection region. You guys remember that formula? Yes? Yes. Okay. So I set up the rejection region. All I've done is set up my test. Where do I get evidence? When I test a hypothesis in the world of statistics, where does evidence come from? How do I get evidence? Because this is hypothesis testing. Max? I survey, I sample, right? So let's say I sample 100 people and I average that together and I get 600. That is my evidence, right? And we call the X bar there, we call it the test statistic. Why? Because it is the statistic that allows me to test my hypothesis. Does that make sense? Yes? So, and this might not be right, but let's say I did this math and this rejection region started at 550. So my evidence is at 600. Is it in there? Is it in there? If the rejection region started at 550 and the evidence is at 600, is it in the rejection region? It is. So we can make two decisions. Decision 1 and decision 2. Remember, decision 1 is if we have enough evidence, we say reject the null in favor of the alternative, meaning we have enough evidence. If there isn't enough evidence, we don't say accept the null, we say do not reject the null in favor of the alternative. Just like in a criminal trial, we don't say accept the innocence or the defendant is innocent, we say they're not guilty, right? We haven't proved their innocence, we've just said there's not enough evidence to find them guilty. So in this case, yes, it's in there. I'd make decision 1. Hey, there's enough evidence to reject the null in favor of the alternative. So that 600 was here. Let's say I'm just visually that 600 was here, and it's in there. It's in the rejection region, and we know it's enough evidence at the 5% significance level, but I also want to know exactly how much evidence I have. What was the value we calculated out to figure out exactly how much evidence we have? What was that value? What was the value we calculated out to find out exactly how much evidence we have? Do you guys remember? The p-value, right? And I would do the math, and let's say the p-value in this case came out to be, I don't know, 0.035, let's say. I'm just throwing numbers out, 0.035. So that tells me exactly the probability of me making a type 1 error, or being wrong if I make this claim. In a word, 0.035 is how much evidence? You guys remember the words we use? This is multiple choice stuff for sure. Very good. If the p-value is greater than 10%, if the p-value is greater than 10%, we say we have no evidence. If it's between 5% and 10%, we say we have weak evidence. If it's between 1% and 5%, we have strong. And if it's less than 1%, we have overwhelming. Okay. That's how all these things come together. And I guess the last thing I should mention is we are just doing samples. We're not asking every man, woman, and child. We're just doing inferential statistics. So we can make decision 1 and be wrong. And what do we call that if we make decision 1 and we're wrong? For example, we convicted an innocent person. What kind of error is that? Or we said the average distance traveled is greater than 500 and we're wrong about that. What kind of error is that? If we make decision 1 and we're wrong, we call that a... If we make decision 1 and we're wrong, Brad, that is a type 1 error. Crazily enough, if we make decision 2 and we're wrong, we call that a type 2 error. Okay? Now those are all the concepts, that will be tested in test 2, which is next Thursday, all right? And on Tuesday of next week, I'll give you a sample exam. Actually, I have that sample exam ready already. But those concepts are really important. I mean, the multiple choice are really important. What a hypothesis is, and what a rejection region is, what a p-value is, and understanding what a type 1 error is and a type 2 error. All those things, those concepts are real important. There'll only be 2 problems on the exam on Thursday. One will be kind of like, remember that one you did in class where you had A through J and you did a hypothesis test of the mean? One like that. And you'll do a hypothesis test of the proportion, which is even easier, right? So only 2 problems. But what I really want to get across to you between now and Thursday is the importance of those concepts, those hypothesis concepts. So we'll spend some time on that on Tuesday. Now, questions? All right. That's kind of a review. And we're going to move on to chapter 11 today. And chapter 11 is no new concepts. In chapter 11, which you're going to be happy to hear this, we are not doing anything new. We're going to do estimation and hypothesis testing, which is something you've done before, right? So if we think about it, one of the first things when we introduced estimation, and one of the first things when we introduced hypothesis testing, we said, we can use the sample mean to make an inference about the population mean. And I gave you 2 primary formulas. I said, if we want to estimate the population mean using the sample mean, I can use this formula. And if I want to do a hypothesis of the population mean using the sample mean, I can use this formula. Here's a problem, okay? And it is a problem, but I kind of glossed over it. But there's a problem with this formula, okay? And I want us to think about what we're doing here. And hopefully maybe you can figure out the problem. So we're using a sample mean. Let's talk about the estimation itself. We're using a sample mean to make an inference about a population mean because presumably we don't know anything about the population. I don't know how many miles you guys traveled over spring break, right? I don't. So I'm going to take a sample, average that together, and I'm going to use that to make an inference about how many miles you actually traveled over spring break. Does that make sense? Yes? So I'm going to use this formula. So I want to go through these things in the formula. This is the sample mean, right? I sample 30 of you, add up how many miles you traveled, divide by 30, boom, I get that. This is the sample size. No problem there, right? It's 30 people, that makes sense. This relates to my confidence level, no problem there. This is a problem though. And we've been kind of brushing it aside, but this is a problem. What is that I circled up there? What is that? What is that? Okay, go a little further. What kind of standard deviation? You're right, it's a standard deviation. What kind of standard deviation? This is the sample mean. This is the population mean. Remember that? So what standard deviation is that? You guys remember? Sigma? What standard deviation is that? Is that the sample standard deviation or the population standard deviation? It is, I will tell you this, it is the population standard deviation. So what? Why is that a problem? I want you to think about this. Why is that a problem? Let's go back to the presumption. I know nothing about the population mean, but I want to estimate it using the sample mean. So if I know nothing about the population mean, what else is probably true? I probably, very good, Kira, I probably don't know anything about the population standard deviation, right? Like if I'm trying to estimate how many miles you guys traveled over spring break, the average for that, if I don't know the population mean, how likely is it that I know the population standard deviation? It's not likely. So that presents us an issue, right? We've been working under that assumption altogether, like, hey, by the way, the population standard deviation is 10. It's given in the problem. Do you guys know what I'm saying? Okay, but that's a bad assumption because many times I don't. But what you're going to like is we can fix it. And here's how we fix it. So these formulas, if we don't use the population standard deviation, what do you think we can use in its place? If we don't know the population standard deviation, what do you think we can use in its place? Any ideas? What do you think might be a pretty good substitute for the population standard deviation? Come on. What do you think might be a decent substitute for the population standard deviation? The sample standard deviation, yes. Okay? The only thing is, when I use the sample standard deviation, the distribution I use has to change. It's distributed differently. It's no longer going to follow the normal distribution or the z distribution. It's going to follow something called the t distribution. It's actually called the student t distribution. Now, I don't want to get into the mud here and get into the details, but let's talk a little bit about the student t distribution, right? So the normal curve, I said at the beginning of this class, is the most important continuous probability distribution, and it is. But it's not the only continuous probability distribution. Another one is called the student t. So the student t is mound-shaped. So some attributes of the student t. Let's do those first. It is mound-shaped. It is symmetrical, just like the normal curve, around 0. And what controlled the shape of the normal curve? Two things controlled the shape of the normal curve. What were they? Two things controlled the shape of the normal curve. What were they? The mean and the standard deviation. The thing that controls the shape of the student t is a value called degrees of freedom. And I don't want to get into the details of that too much. Just know that there is a parameter, and it's called nu, okay? It's called nu, N-U, and it looks like a cursive V. That is the degrees of freedom. It controls the shape of it. Are you lost, Tommy? No? Okay. So let's go back. Let's start again. I'm saying that we used these formulas to estimate the population mean when we didn't know it using the sample mean. We said there's an inherent issue in that formula. If we don't know the population mean, it's not bloody likely that we know the population standard deviation. So I said, how we can correct that is instead of using the population standard deviation, we're going to use the sample standard deviation. However, when we do that, it changes the distribution that we use. Instead of using the z distribution, I need to use the student t. The student t distribution is a continuous probability distribution that is mound-shaped, it is symmetrical around 0, and the thing that controls the shape of it is the degrees of freedom. Now that's a lot of the theory and the practice. That's why we do this. How we're going to actualize this, though, is a little bit different. Okay? So what I want to do now, we're not going to do any of these problems by hand. We're not going to use the student t-distribution by hand. We're going to use Excel. Okay? I think that's the best way to do this. So let's do one together, and then I'm going to have you guys do one, and we'll go that one out. So this is in chapter 11. Now let's do number 10. In chapter 11. It says Office Max. I guess that's supposed to be like Office Depot, I guess. A chain that sells a wide variety of office equipment, often features sales of products whose prices are reduced because of rebates. Some rebates are so large that the effective price becomes zero. The goal is to lure customers in the store to buy other non-sell items. A secondary objective is to acquire addresses and telephone numbers to sell to telemarketers and other mass marketers. During 1 week in January, Office Max offered a 100-pack of CD-ROMs. That's kind of a joke question, right? No one buys CD-ROMs anymore. Regular price $29.99, minus a $10 instant rebate, $12 manufacturer's rebate, and $8 Office Max mail-in rebate. The number of packages was limited and no rain checks were issued. In all the Office Max stores, there were 2,800 packages in stock. All were sold. A random sample of 122 buyers was undertaken. Each was asked to report the total value of other purchases made that day. Estimate with 95% confidence the total spent on other products purchased this day. So you think about it. Okay, this is a good marketing example. So someone comes out with this idea, hey, we want people in our store. The way we're going to do that is we're going to basically give them this free thing, right? People come in and we're hoping that they buy something else, right? But for that to be profitable, we have to have them buy something of significance, right? So we want to estimate how much these customers spend on non-free items, basically, yes? So let's pull up that data. So I'm going to go to Blackboard. God bless you. And let's go to Book Excel Files, Chapter 11. And this is XR 11-10. Okay, so the first person bought $49.59 worth of other items. This person didn't buy anything. This 50th person didn't buy anything extra. The 78th person didn't buy any. It looks like we have 122 values. Okay, so what are we trying to do here? Let's just in layman's terms, tell me in English, what are we trying to do here? Eric, what are we trying to do? What are we trying to estimate? What are you trying to do, Eric? Just you're tasked with this. What are you trying to do?
Figure out the sales compared to that other.
Okay, very good. We know we're giving away the farm with these CD-ROMs, right? So we want to estimate how much these customers spend on other items to see if it makes sense to give away the farm, yes? So we want to estimate this. We want to estimate the population mean using the sample mean. Let's go back to book material by chapter. Let's go to chapter 11, inference about a population. And remember our estimators workbook? Do you guys recall that? Yes? So let's pull that up. What were we using before to estimate the mean? We were using z-estimate of a mean. Yes? Yes. We give it a sample mean, a population standard deviation, a sample size, and a confidence level. I could get the sample mean. Go ahead, John.
What's the workbook under again?
If you go under chapter 11, and it's called estimators. Okay. I get the sample mean, right, from that data. I get the sample size, I think it's 122, I know that. And the confidence level is 95%. But I can't get the population standard deviation, right? Because the population standard deviation, I don't know what it is. So this is a problem. Z-estimate means a problem. What did I tell you we need to use? And we don't know the population standard deviation. In this case, we don't. Very good. So all I really need to do is to go to the next tab in my workbook. And it says T-estimate mean. And if we look at the input for this one, it says I need the sample mean, I need the sample size, I need the confidence level, but it also needs not the population standard deviation, but what? The sample standard deviation. So even though we were kind of using the sample standard deviation for the population standard deviation in previous problems, because I didn't want to get into that detail, it was really wrong to do so. You guys understand why we use t-test or t-estimate mean instead of z-estimate mean? If we don't know the population standard deviation. So let's do it, right? Let's do this one. So I'm going to go to 1110. And how am I going to analyze this data? How am I going to analyze this data? You guys recall? Data analysis, descriptive statistics. My data is an A1 down to A123 is grouped in columns. There are labels in the first row. I want a new worksheet ply. I want summary statistics. I click OK. It builds a little table for me. I'm going to copy that table over to estimators. All right. I'm going to plug these values in. The sample mean is 59.043. The standard deviation, the sample standard deviation is 20.625. The sample size is 122. And the confidence level is 95%. I know now that the average amount of money spent by people that come into my store for this deal is somewhere between $55.35 and $62.74. If I know 1,000 customers came into the store during this weekend for this CD-ROM deal I had going on, can I estimate how much my sales were associated with that CD-ROM sales? How would I do that? I didn't ask you that in the problem, but if I was your boss, I would ask you that. How could I do that, Max? If we're saying on each sale, the average amount spent outside of CD-ROM products is somewhere between $55.35 and $62.74. And we know 1,000 of these CD-ROMs, these special CD-ROMs, these special items were purchased. And I estimate how much our sales were for those customers. If there are 1,000 of those, I can. Total sales, how could I estimate that? Mr. Myers? Change what? No. The sample size is the sample size. Jonathan?
Mean?
What about the mean?
Change it.
No, because the mean is the mean, man. We sampled 122. We came up with 59. I'm saying, maybe I'm not saying it right. I'm not saying it right now. So if I estimate on average, you guys send 100 texts per day, and there's 30 of you. I want to know how many texts in total are sent. How would I do that? I would say 100 times 30, right? So Brad, what would you do here?
We just average it through and multiply that.
Okay, well,
Just multiply by 1,000.
yes, right? So if I'm saying the average extra money spent because they came in my store for this CD-ROM special is somewhere between $55.35 and $62.74, and we know 1,000 people came in and purchased that CD-ROM, I can multiply this and this by 1,000 and say, oh, okay, somewhere between $55,000 and $62,000 worth of sales, additional sales can be credited to this special. You know what I'm saying? And I think about that. Like, it's really fascinating. Some of you guys are in marketing. Like consumer behavior is like, there's people that study consumer behavior, like how, like a grocery store is set up like a trick. It really is. It's like when you go in a grocery store, it's kind of a psychological experiment. Like any grocery store you go in, a good one anyways, where's like the commodity items like milk and bread? Why? Because they want you to walk the whole way through the damn store. Where are things that you really don't need, but you might have some time and you might be looking around? Where are those items? What's that? Right at the cash register. What do they even call those items? Impulse buy items, right? Like you're like sitting there and you're like, oh, Barack Obama, on vacation, maybe I'll buy that Star or whatever the hell it is. You know what I mean? Or, oh yeah, I could use some breath mints. You know what I'm talking about? Why is that there? That's because they know how you work. My brother manages a Lowe's. He's managed several Lowe's stores, but he told me, like, if you just take, like, if he takes air conditioners that are like nothing special, like just air conditioners, like not a special price or anything, but it doesn't change the price, but if he stacks them near the entrance to the store, like in a pyramid shape, those things sell like hotcakes. Because people think, holy shit, they stack these in front of the store, there must be something special about them. And people buy them, right? Do you know what I'm saying? Like, it doesn't change the price of them at all. Isn't that crazy? But that's how, things happen. So when you see like giveaways and stuff like that, there's always something behind it. And even in that little thing, sometimes you say, oh, I can get this something free if I just give them my information. You're saying, well, what's in it for them? They're just giving me something free. They're selling your information. They're selling your email address, so that's why you get spam or whatever it might be. You think about it, there's different layers to ways that these organizations are working with us or working kind of against us in some cases. I don't know. Like pricing. Do you ever see why things are always priced with like 99 cents? And because that's the way the mind works. Where are the brand name items? Like if you go to I don't know, I talk about toaster pastries, Pop-Tarts are here, right? Pop-Tarts are here. Where are the Walmart toaster pastries? Down here, right? Because they want you to buy the higher priced items, yes? End caps. Retailers, what I mean by end caps, when you're walking around aisles, those end caps, they pay a premium to be there because you spend more time there. All right. So I don't want to get into a consumer behavior type of example, but here's what I want you guys to do. I want you to do number 12 in your book right now. This is old days. This is 2001 Super Bowl game. Does anyone know how much Super Bowl ads were this Super Bowl? I think it was like 3.8 million, something like that for 30 seconds. Does anyone know? Maybe I'm wrong. Maybe it was 5. Maybe it is 5. Yeah, 5 million. Oh, no, I don't want you to do that one. Not yet. I'm sorry. Because that's a hypothesis. We'll do that one eventually. Let's do... Let's do number 8. I'm sorry. That's an estimate one. We'll do number 12 in a second. Bless you.
your socks are tough. My youngest son's into like crazy socks. He has like hot dog socks. And, seems like that's a thing now, crazy socks. Is that a thing?
Yeah, it's kind of strange.
Yeah, he has quite a assortment. He's kind of a goofy kid. How's London? Who went to London? Was it a good time? Good time, yeah. You robbed, I heard that? You robbed? You weren't hurt though, right?
No.
How much you lose? Pounds or $8 pounds? So what's that, like $200 in US? Yeah. Oh, exchange rate's pretty favorable right now. You go home, Mr. Boy? No. DC.
All right, let's take a look at this one. It says, a growing concern for educators in the U.S. is the number of teenagers who have part-time jobs while they attend high school. It's generally believed that the amount of time teenagers spend working is deducted from the amount of time devoted to schoolwork. My 17-year-old son has a part-time job, and I can tell you his grades have suffered. To investigate this problem, a school guidance counselor took a random sample of 200 15-year-old high school students and asked how many hours per week each worked at a part-time job. Estimate with 95% confidence the mean amount of time all 15-year-old high school students devote to part-time jobs. So I'm trying to estimate the average number of hours that 15-year-olds spend working at part-time jobs. To that end, looks like I've sampled 200 15-year-olds. So I'm going to go to chapter 11, XR 1108. And we don't know the population mean, so if we don't know the population mean, what also don't we know? We don't know the population standard deviation, right? So I can get the sample standard deviation, I can get the sample mean by using my good friend data analysis. So I'm going to say data analysis, descriptive statistics, A1 through, through 201. Labels in first row, new worksheet reply, summary statistics, click OK. Gives me back this little table. I'm just going to copy that information over to my estimator's workbook. I'm going to copy it over the CD's one. So I'm going to copy the mean up to the sample mean. I'm going to copy the standard deviation to the sample standard deviation. The sample size, I believe, is 200. And it tells us now that I'm 95% confident that the average number of hours spent working by 15-year-olds at part-time jobs per week is somewhere between 6.92 hours and 7.38 hours. Okay? So very powerful stuff. Let's do a hypothesis test. Okay, let's do a hypothesis test. And then what I want to do is number 14. So why don't you guys, instead of us doing two, why don't you guys take a shot at this one? This is a hypothesis test. And I want you to think about it. If I don't know the population standard deviation, I'm still going to use the test statistics workbook. But instead of using z-test mean, what do you think I'm going to use if I don't know the population standard deviation? If I don't know the population standard deviation and I want to test the mean, instead of using z-test mean, I'm going to use t-test mean. Right? But we've done this before. So try number 14. Try number 14. Where did I put my coffee?
On the windows.
Oh. Okay, so let's take a look at it. It says, companies that sell groceries over the internet are called e-grocers. And this is becoming, this is an old question. It's becoming much more prevalent, especially in like bigger cities. There's a premium, I think it's like 12, it's a flat rate. I can't remember you guys know the one that's kind of taken off? I read an article about it, but I think they charge like $12 additional, you know what I mean? So that's the fee. There's also abilities to have like takeout and stuff, Uber to your house. You guys, ever see those kind of things, or groceries Uber to your house. So anyways, this is becoming much more prevalent. Customers enter their orders, pay by credit card, and receive delivery by truck. The potential e-grocer analyzed the market and determined that to be profitable, the average order would have to exceed $85. To determine whether an e-grocery would be profitable in one large city, she offered the service and recorded the size of an order for a random sample of customers. Can we infer from these data that an e-grocery would be profitable in this city? So, step one, what is the hypothesis we're trying to prove here? What are we trying to prove? Come on, help me here. What are we trying to prove? We're trying to prove what? Very good. That the average order is greater than $85. So that means the null is equal to 85. So let's go look at the data. So I'm going to go to Blackboard. This is number 14, XR11-14. And we have recorded the results. Here are the orders. The first one was $83.30, $91.13. I'm not going to use the estimator workbook. I am going to go to chapter 11. I am going to use the test statistics workbook. And because I'm testing something, I'm not estimating something. And specifically, what tab do I want to use in this workbook? T-test mean. T-test mean requires the following things: the sample mean, the sample standard deviation, the sample size, the hypothesized mean, and alpha. So let's get the sample mean, the sample standard deviation, and the sample size. I already know the hypothesized mean is 85. I'll leave my alpha at 0.05. The other things I need to get, so data analysis, descriptive statistics, new worksheet ply, summary statistics. Data goes from A1 the whole way down to A86. Labels in first row, summary statistics, click OK. Looks like my average order was $89. Let's copy this over. So 89.266. The sample standard deviation was 17.2964. The sample size was 85 as well. I'll just leave alpha at 0.05. Based on this evidence and looking at one value, I can tell you how much evidence we have to support this e-grocer's claim that this will be profitable. How much evidence, in a word, do I have to support this claim? What one value do I want to look at? The p-value, and the p-value in this case is 0.0128. In a word, how much evidence do I have? I have strong evidence to infer that this will be a profitable grocery store. Does this make sense? So here's what I want you to do for homework in this section. Don't leave because I want to go over your take home as well. I would like you to do number 12 and 13. Let's just do 12 and 13. One is a hypothesis test, and one is an estimation. 12 and 13 on page 181. That's it. Okay, do that with Excel. Okay, the other thing that I want to spend some time looking at is out here on Blackboard under take-home assignments. I have your second Excel assignment due. It says March 17th, but that's the 16th, right? Next Thursday is the 16th. So this is due. I have this all screwed up. I want it to be due next Tuesday. Let me change that. It's due next Tuesday, okay, so a week from today, so you can start on this now. Using Microsoft Excel, the provided workbooks, and your vast knowledge of inferential statistics, please complete the following exercises which can be found in your course text. There's only 4 questions here, okay? All 4 are hypothesis tests. The first 2 are using the z-test of proportion. So we're trying to prove something about a proportion, right? The first one is, Dr. Miko is trying to claim that less than 50% of people watches lecture captures. So we're trying to prove it's a left tail test, right? That P is less than 50%. He's also trying to prove that more than 50% of people, more than 90% of students have watched a music video on YouTube. The data for that is in this workbook. Students watch what? This is the lecture capture. This is watch a music video on YouTube. We'll use z-test proportion to analyze that data. Does this make sense? The third and fourth one are both test of a mean where we don't know the population standard deviation, so we're going to use t-test means. Very much like you're doing for your homework, right? So these are both problems, a little bit different, but kind of the same thing, okay? So the data files are here. The hypothesis testing workbook is linked here. You guys, that's the workbook you need to use. And all of your work should be copied into one Word document and uploaded to this assignment. So you're not going to print these out. That's a little bit different. You're going to upload it to this assignment, okay? And it's worth 20 points. So this is using some of the stuff we've done in class, outside of class. It's due next Tuesday, so a week from today. Remember, we have an exam Thursday, so might be something that you want to get out of the way early, right? So get this out of the way early. You have a week to do that, and reserve the rest of the week for getting your exam. Okay. No Miko facilitated class on Thursday. You will come here, get in your groups, and work on putting your survey that you've already designed, hopefully, into Google Forms, Google Survey. You will submit that via Blackboard under assignment 2. Only one person from your team has to submit that, yes? So I'm giving you that class time, 75 minutes, to work on your group project. On Tuesday of next week, we're going to come back together and we'll start getting ready for your exam 2, which is Thursday. You also hand in this assignment. So we've got a lot going on. I know I'm not going to be here for part of it, but learning continues, right, Tom? Always right. So questions? I'm also available on Google Hangouts. Any points? You want to hang out with Dr. Miko? Boom, right there. Have a great week. And look for an email from me about the video using Google Forms and Survey.
All right, see ya.
Okay.